Hey folks, so we're back with an update on where we're at with the two-wheeler balancing robot. We've got the prototype board complete. We've got the chassis largely complete mechanically, as far as I'm concerned. So I wanted to take you through where we're at with that before I start tuning today. So the board itself, you've sort of seen the layout on the breadboard earlier, but this is what it looks like now. I've not tried to optimize for space. Got the buck, the MPU 6050, the ESP32S3, 2 motor drivers and some screw terminals for mounting or for connecting the motor to the drivers. I've got the power management at the front here, so this is obviously an on-off switch. I've got a diode here to protect in case I don't know, connect things the wrong way around, try and run current in the wrong direction. And I've got a battery sense here, so battery level sense. I've got a pull-up resistor here, which is used for enabling the motor drivers and controlling that with the ESP. And I've got my cap protection on VMOT and ground for the motor drivers. I can't remember what these are, 300 microfarads or something, 330 microfarads or something like that. So they're only rated for 25 volts. I never intend to put more than a 4S battery on this thing. It's been designed for that. So when I put 14 volts in, for example, so nominally I'll be probably powering it with 14 to 16 volts with a 4S battery. I'm going to flag anything below 13.5 volts and shut everything down just for battery health, and then flag a low battery warning. And that's all managed via this this pin here. So when I'm putting 14 volts in, I can see 2.4 volts here, which goes to an analog pin on the ESP, and then I can convert that to a voltage and work out what that looks like and flag appropriately in the firmware, which I'm doing. So that's all working nicely. Power in kind of is a bit clunky right now. So upstream of this, I'm going to have a fuse and then an XT60 connected to the LiPo battery. I've got a 4S battery from previous experiments, so I'm going to use that. And so I'm still waiting on the fuse and the battery, the fuse and the XT60 connector. I've got a fuse holder. It's pretty janky, cheap thing from JCar. It's like $1.50 or something. That is probably going to be mounted at the top of here somewhere. And then obviously the board will mount in here like this. I've got those on 10mm risers at the moment. These are little nylon risers that I've just mounted into the frame here. And that all screws in with M3 screws, bolts, that all works very nicely and easily. So power at the front isn't really kind of complete, but from the switch down it is. So I switch into diode into the positive in on buck. I've mounted the buck above the PCB, which is kind of funky, I think. I'm not sure why I did that, but I just wanted to avoid shorts, and it's not like I need extra air circulation or cooling here. But you can see two ins there. Basically, one of them is in from the diode, and then the other one is basically going to be feeding this higher voltage rail, which goes down to VMOT on the back of the board. So that's what those two wires are. Otherwise, it's just, I've connected one wire everywhere else. Let's look at this. I've sort of tried to be careful here with color convention. So I've used red for the high voltage power rail, which is 14 and 16 volts, for example. Blue is the 5-volt rail. So that's everything that comes out of the buck. I feed just about everything with that apart from the IMU. So that goes into VUSB on the ESP32. It goes into VDD on the motor drivers. I pull a couple of things high. So I've got, the sleep and reset pins on the drivers pulled high to 5 volts, or powered at 5 volts. So I've used blue for the 5-volt rail. I've used green for 3.3. That is just coming out of the 3.3 volt pin on the ESP32. All that does is feed the IMU. That's all it does. Or does it do something else? Oh yes, it does do, okay. I do connect the enable pins on the motor drivers to a pull-up resistor to 3.3 volts. So they're pulled high on that path until the ESP pulls it low. So that all should work nicely. And that's that pin there. I think it's D9. I can't remember exactly what the pin is. So that works nicely. And everything else is kind of complete. I've used yellow for analog. I've used white for signal. So this is my I2C clock and data from the IMU to the ESP32. Very short connections there, only 1 centimeter or so that's good. In hindsight, the wire gauge was a bit thick. You can kind of see it was a bit challenging at times to solder everything neatly, but it works. Ground, I took care to try and avoid noisy ground, getting close to the ESP ground. Don't think I really needed to do that, but I've got this star distribution pattern up here. So ground comes directly in, obviously, from the battery here. So the fuse will connect through here, and then the battery ground will, negative terminal will go straight into ground, and then that gets distributed to the buck and everywhere else. And that works fairly well from what I've seen in testing. And then the motor colors here, kind of confusing. I've mapped them directly to the colors on the wires coming out of each motor, which I don't think is a convention. It's probably arbitrary, but it means that when I'm wiring these things into my screw terminals, it's easy. I just go, okay, yellow to yellow, and there's no confusion there about what coils map to where and what have you. So that's straightforward. So that's the wiring at the back, and the front of the Perfboard complete. Now the chassis is also complete. So you've all seen this, I think, in the previous video, where I have a simple box that I've built. That's all a bit rough, but it works. It's structurally, it's good. M3 bolts mounting each stepper motor. I've got my coupling here, my hex coupling to the stepper motors, and that all works nicely with an M3 screw through there. And so that's pretty convenient. I will probably I'll route power through the side here, I think. So I'll have 4S battery at the top with the fuse probably, and then I'll have power coming in so that it maps to the right side of the board in here, and then that'll go straight into the circuit there. So we're at a point now where we've got the chassis and the board complete electrically. That you won't see that again really, because I'll have that mounted from today onwards. But that's what it looks like. I have used, just before we move on, I have used epoxy under some of these pieces, like under the caps, and to hold down some of the longer runs, just to make sure they don't flap around and they're not. There's going to be vibration on this thing as the stepper motors move, so I just wanted to make sure I don't have any issues with things strain on wires or things rattling loose. I've also added quite a bit of epoxy support around the switch, so that's all very secure now. So from today onwards, we're going to be basically mounting board, connecting motors, stripping those, and making sure that all works, and then powering the board. Given that I'm waiting on fuses and the XT60 connector, I am in a situation, I don't want to block on that, so I'm going to be tethering the board for the first few tuning balancing sessions to my bench supply, which is not ideal, but it means that I can continue, and I'll just be careful around holding the thing while it's trying to balance in the first few iterations. So that's where we're at. Thanks for following along. The next video should be an update of the robot, either with battery power or maybe just some of the first few tuning efforts with bench supply connecting to the robot, and we should start to see the PD loop doing the right thing. The other thing that I've done, I've changed the firmware quite a bit over the last couple of weeks. I'll go through that in a separate video, probably a screen sharing session where I step through the code and what I've done there. The bit that's kind of interesting is, because I'm using ESP32 and I've got BLE, low power Bluetooth, what I'm able to do is extend the Bluetooth user control to do things like calibration. So what I've got, for example, right now I've calibrated the board in this position, right? What I will be needing to do is calibrate the board in this position in vertical. And I don't want to have the ESP connected over serial, over USB to do any of that. So what I've got is I've got a routine that calibrates the ESP, the MPU, I should say, calibrates the MPU. That has been tested and works well, and that's a separate little library that I've got in my project. What I've done is I've extended Bluetooth commands to allow me to send a command to calibrate over Bluetooth. So I can, from my phone, I can say calibrate the robot, and then I've got another BLE characteristic that I've used for system status, and it'll say, you know, basically I can subscribe to that and watch updates there, and it'll say calibration started, calibration successful, or calibration failed, or whatever, and watch the calibration happen. And then what it does is it'll write, if it's successful at calibrating the NPU, it'll write the calibration data to the ESP flash. So I'm using the preferences library to do that, and that seems to be working quite nicely. So I can, in the fullness of time, when I have a richer app that I'll build for my phone, the idea is to have, you know, a separate Android app that lets me do teleop and control. That's probably the next stage after this tuning work that I'm about to start. That will then allow me to, I'll obviously be pushing battery status to that. I'll be able to control the robot forward, back, turn, whatever with that, but I'll also be able to do things like calibrate and probably get simple telemetry back as well, looking at tilt and pitch. And I don't think I'll be streaming full PID sort of telemetry, but I'll be able to basically get telemetry from the robot, battery status, that sort of thing. So that's where we're at with that. So I'll be using that ability to calibrate and control the robot. At least calibration I'll be doing during tuning. But I'll do a separate video on the software side because it's starting to get a bit more interesting now. So that's where we're at. Thanks so much, everyone. Thanks for watching the videos, and please leave comments below because there's been some interesting ones already, and it'd be great to get a couple of conversations going about this. See you in the next one.